There are things we were never meant to find. Buried in the dark corners of the human mind, hidden in the silence between the stars, locked inside files that someone hoped you'd never open. Welcome to Shadow Intel. Right now, as you listen to this, there are machines pointed at the sky, listening, recording, waiting for something to answer. And sometimes, something does. A scream from the dark that arrives once and never returns. A voice from the edge of the solar system that forgets how to speak. A signal rising up out of the earth that should not exist. The files are real. The recordings are real. And the people who study them still cannot explain what they found. You are about to hear them. Every one. So turn the lights down and listen closely. Because the universe is trying to tell us something. Space is supposed to be silent. No air. No medium for sound to travel through. A vacuum so complete that a scream from one end of the solar system would never reach the other. And yet, we keep hearing things we cannot explain. For more than half a century, humanity has been listening, pointing dishes the size of football fields at the dark, recording, waiting. And every so often, something answers back. A pulse, a tone, a pattern that shouldn't be there. Tonight, we open the files. The recordings that made veteran scientists go quiet in the control room. The signals that arrived once and never returned. The transmissions that, decades later, still have no agreed explanation. These are the signals NASA, and the rest of us, still cannot explain. August 15th, 1977. Ohio. A radio telescope called Big Ear sat in a field, scanning the heavens for anything unusual. It was an automated machine, patient and indifferent, printing its findings onto sheets of paper in long columns of numbers and letters. Most nights, the numbers were boring, background static, the low hum of an empty universe. But on this night, the machine recorded something it had never seen before. A few days later, an astronomer named Jerry Eman sat down with the printouts. His eyes moved across the rows of ones and twos, the ordinary noise of space, until they stopped dead. There, in a single column, was a sequence so loud, so sharp, so wildly out of place, that he grabbed a red pen, circled it, and wrote a single word in the margin. Wow. The signal lasted 72 seconds. It came from the direction of the constellation Sagittarius, and its frequency sat almost exactly on the so-called water hole, the band near 1,420 megahertz that scientists had long predicted an alien civilization might use to make contact. A quiet channel, a natural place to whisper across the galaxy. The intensity rose and fell in a perfect arc, exactly the shape you'd expect from a fixed point in the sky as the Earth's rotation swept the telescope past it. It behaved like something out there, not something here. And then it was gone. Eman and others pointed the telescope back at that same patch of sky. Again and again, for years, decades. They listened to that exact spot dozens of times. Nothing. Silence. The signal never repeated. To this day, no one knows what sent it. Comets have been blamed. Hydrogen clouds. Earthly interference bouncing off space debris. Every explanation has been proposed, and every explanation has been picked apart. The truth is uncomfortable for science, because science demands repetition.
a result you can reproduce. And the wow signal did the one thing a real discovery is never supposed to do. It happened once, and it refused to happen again.
Let me tell you about the loneliest object ever built by human hands. Voyager 1. Launched in 1977, the same year the wow signal screamed across Ohio. A machine the size of a small car, flung outward at over 35,000 miles an hour, never to return. For more than 4 decades it sailed, past Jupiter, past Saturn, out beyond the planets, out beyond the heliosphere, the great bubble of solar wind that marks the edge of our sun's influence, until it crossed into interstellar space, the void between the stars, where no human-made thing had ever gone. It is now more than 15 billion miles away, so far that its radio whisper, broadcast with the power of a refrigerator light bulb, takes nearly a full day to reach us. And then, in 2024, it started speaking nonsense. The data coming back stopped making sense. Instead of clean readings, Voyager 1 transmitted a repeating, meaningless pattern, a loop of gibberish broadcast faithfully across 15 billion miles, like a man talking in his sleep, like a voice that has forgotten the words, but not the rhythm. The engineers at NASA's Jet Propulsion Laboratory faced a problem no one had ever faced. How do you repair a computer that you cannot touch, that is so far away each instruction takes 45 hours to arrive, running on technology designed in the 1970s with less memory than a modern greeting card that plays a song? They had to perform surgery on a patient at the edge of the solar system, blind. They traced the fault to a single failing chip, a tiny piece of corrupted memory. And in an act of almost unbelievable engineering, they rewrote the spacecraft's code, sliced it into pieces, and tucked those pieces into the working corners of a dying machine. Months passed. Commands crawled outward at the speed of light. And then, finally, Voyager spoke clearly again. But here is the part that lingers, that keeps engineers awake. One day, soon, the voice will stop for good. The plutonium that powers it is fading, watt by watt, year by year. And when the last instrument shuts down, Voyager will keep flying, silent, forever, carrying a golden record of human voices and music into a darkness it will never report back from. It will outlive every person listening to this. It will outlive the Earth itself. 1967, Cambridge, England. A young graduate student named Jocelyn Bell was analyzing miles of paper chart recordings from a radio telescope she had helped to build by hand. She noticed a smudge, a bit of scruff, she called it, a faint, fast signal that didn't fit any known source. When she examined it closely, she found something that stopped her cold. A pulse, then another, arriving with impossible precision, every 1.33 seconds, as regular as a heartbeat, as regular as a clock. Nothing in nature was supposed to be that precise. The regularity was so machine-like, so artificial, that the team only half-jokingly labeled the source LGM1. The letters stood for Little Green Men. For a few electric weeks, a handful of scientists in England held in their hands what looked like it might be a signal from another civilization. A perfect rhythmic beacon pulsing from deep space. Then Bell found a second one, in a different part of the sky, pulsing at a different rate.
It was unlikely that two separate alien civilizations would both happen to be broadcasting metronomes at the Earth, so the explanation shifted. These were not messages. They were a new kind of object entirely. The collapsed, spinning cores of dead stars, sweeping beams of radiation across the cosmos like cosmic lighthouses. We call them pulsars now. But for those few weeks, the most rational minds in science genuinely wondered if someone was calling. And that is the lesson buried inside this story. The line between natural phenomenon we don't understand yet and signal from something out there is thinner than we like to admit. It is sometimes only a matter of how many more times the universe lets us look.
Some signals don't repeat. Some signals don't last. Some signals are over before you could even say the word signal. In 2007, astronomers reviewing old data found a flash. A burst of radio energy so brief, it lasted only a few thousandths of a second. Yet in that fraction of an instant, it released more energy than our sun puts out in days. They called them fast radio bursts, FRBS. They come from billions of light years away, far outside our galaxy. They arrive without warning. Most flash once and vanish, never to be seen again, and for years, no one had the faintest idea what could possibly produce them. The theories ranged from the violent to the bizarre: colliding neutron stars, collapsing black holes, the death throes of exotic objects we have never directly observed. And yes, quietly, in serious scientific papers, the possibility of artificial origin. Power beamed by a civilization to push light-sail spacecraft across the galaxy. Then it got stranger. Some of the bursts began to repeat, and one of them, discovered later, repeated with a pattern, active for several days, then silent for several days, then active again. A rhythm, a cycle. And in 2020, for the first time, a fast radio burst was traced to a source inside our own galaxy. A magnetar. A dead star with a magnetic field 1 trillion times stronger than Earth's, twitching and flaring in the dark. That solved some of the mystery, but not all of it. Because the bursts that repeat in patterns, the ones with structure, the ones that almost seem to organize themselves, those still don't have a clean answer. We are detecting thousands of them now, cataloging them, and every catalog raises more questions than it closes. Somewhere out there, across distances the human mind cannot truly hold, something is flashing, over and over, and we are only beginning to learn its language. Not all unexplained signals are sounds, or pulses, or bursts. Some are absences, holes, places where something should be and isn't. When we look at the oldest light in the universe, the faint afterglow of the Big Bang itself, the cosmic microwave background, we see a remarkably even glow. Tiny ripples here and there, but smooth overall, as expected, except in one place. There is a region of the sky known simply as the cold spot, a patch far larger and far colder than the models say it has any right to be. An enormous stretch of the early universe that is somehow missing energy, missing matter, a void hundreds of millions of light years across. No one is sure why it exists. The leading explanation is a supervoid, a vast emptiness, the largest known structure in the cosmos, draining energy from the light that passes through it. But the numbers don't quite add up. The void may not be large enough to explain the chill. And so other ideas crept in. Quieter ideas, stranger ones. What if the cold spot is a bruise?
the mark left behind by another universe colliding with our own in the deep past. In some theoretical models, our universe is not alone. It is one bubble among countless others. And if two bubbles touched, they might leave a scar. There is no proof, there may never be. But the cold spot remains, a stubborn, frozen question mark printed onto the very first light there ever was.
In 2015, astronomers using the Kepler Space Telescope, a machine built to find planets by watching for the tiny dimming as they cross in front of their stars, found a star that was doing something deeply, profoundly wrong. Its name was Tabby's star, and its light was flickering in a way no planet could explain. Normal planets block a fraction of a percent of a star's light in a clean, predictable dip. Tabby's star was dimming by as much as 22%, irregularly, unpredictably, as though something vast and ragged and complicated was passing in front of it. Astronomers ran the numbers. No single planet could do this. No ordinary disk of dust. The dips were too deep, too chaotic, too strange. And so, in 2015, a serious scientific paper raised a possibility that made headlines around the world. An alien megastructure. A swarm of artificial objects. A vast construction built by a civilization to harvest the energy of its own sun. The kind of structure theorists had imagined for decades, but never expected to actually see. The world held its breath. In the end, the most likely explanation turned out to be dust, uneven clouds of fine particles, dimming the bluer light more than the red, exactly as dust would. Not engineering, not aliens, just an unusually messy stellar neighborhood. Probably. But probably is doing a great deal of work in that sentence, because the truth is that the behavior of Tabby's star has never been fully, completely, satisfyingly explained. The dust model fits most of the data, most of it, and in the gap between most and all, the mystery still breathes. In the frozen silence of Antarctica, an experiment called Anita hung beneath a high-altitude balloon, scanning the ice for the faint signals of cosmic particles raining down from space. It was designed to detect particles arriving from above, from the sky, from the stars. But twice, it detected something coming up, from below, from inside the Earth itself. A high-energy signal rising out of the solid ground, as though a particle had passed clean through the entire planet and emerged on the other side. According to everything we understand about physics, this should be nearly impossible. The particles in question, neutrinos, can pass through matter, yes, but at these enormous energies, the Earth should have absorbed them completely. They should never have made it through. And yet, the detector recorded them. Twice. Coming up. Out of the world. The explanations have piled up over the years. Reflections off the ice. Unusual conditions in the Antarctic snow. Quirks of the detector. And the boldest of all, that Anita had glimpsed evidence of physics beyond the known. New particles. Hidden dimensions. A crack in the foundation of what we think the universe is made of. The debate is ongoing. No single answer has won. Somewhere beneath the ice at the bottom of the world, the question still stands. Something came up that should have stayed down, and we still don't know what it was. Here is the question that haunts everyone who works in this field. The question underneath all the others. The universe is vast, almost beyond comprehension. Hundreds of billions of galaxies, each with hundreds of billions of stars. Each star, we now know, likely circled by worlds. The numbers are so staggering that, by every reasonable estimate, the galaxy should be teeming with life, with civilizations, with signals. So where is everybody? This is the great paradox. We have listened for more than 60 years. We have built ever larger ears and pointed them at ever more of the sky. And what have we heard? A scream in 1977 that never came again. A pulse that turned out to be a dead star. Bursts we are only beginning to understand. A cold spot, a flickering star, a particle from beneath the ice. But never a message. Never a clear, unmistakable, repeating hello from another mind. And there are only a handful of explanations for that silence, none of them comfortable. Perhaps life is far rarer than the numbers suggest. Perhaps we truly are alone, the only ones who ever woke up and looked out and wondered. Perhaps the distances are simply too great. Perhaps civilizations rise and fall like sparks, never overlapping long enough to find one another across the dark. Or perhaps, and this is the thought that lowers the temperature in the room, perhaps everyone else is being quiet, on purpose, listening as we listen, afraid to call out into a dark they don't understand, waiting to see who answers first.
Every signal in this story has something in common. The wow signal, Voyager's broken voice, the bursts, the cold spot, the flickering star, the particle from beneath the ice. Each one arrived. Each one was studied by serious people with serious instruments in the brightest light of reason we can muster. And each one left a residue, a question that wouldn't fully dissolve, a gap between what we observed and what we can explain. That gap is where the real work lives. Not in the easy answers, but in the stubborn ones that won't resolve. Because the history of this field is the history of mysteries that looked impossible until one day they didn't. The pulsar was once little green men. The fast radio burst was once pure science fiction. The unexplained has a habit of becoming the understood, given enough time, enough listening, enough patience. But not all of it. Not yet. Some of these signals are still out there in the files, circled in red pen, marked anomalous, waiting for a future scientist, maybe one not yet born, to finally read them correctly. And somewhere, right now, a dish is turning toward the dark, recording, listening. Because the strangest possibility of all is not that the universe is empty. It's that it isn't. And that the next signal, the one that finally doesn't go away, the one that repeats and repeats and repeats, could arrive tonight. We are still listening. We are always listening. The only question is what we'll hear. That's where we'll leave it tonight, in the dark, with the dishes still turning. If something in this kept you listening, do me a favor. Leave a comment with the one signal that unsettled you the most. I read every single one. And if you want more files like these, more questions science can't close, subscribe. Turn on the bell so you're here when the next one drops. Until then, keep looking up. Something out there is looking back. Good night.